SpaceX is a private American aerospace manufacturer and space transportation services company founded by entrepreneur Elon Musk in 2002. The company's primary goal is to reduce the cost of space transportation and enable the colonization of Mars. Some of SpaceX's major achievements include the development of the Falcon 9 rocket, which became the first privately developed rocket to reach orbit in 2008. The successful launch of the Dragon spacecraft, which became the first privately developed spacecraft to dock with the International Space Station (ISS) in 2012. The successful landing of a Falcon 9 rocket's first stage booster on a drone ship in 2016, paving the way for reusable rockets and reduced launch costs. The successful launch of the Falcon Heavy rocket, which became the most powerful operational rocket in the world in 2018. The ongoing development of the Starship spacecraft, which aims to eventually transport humans to Mars and beyond. SpaceX has also been awarded several contracts from NASA, including a contract to transport astronauts to and from the ISS using the Dragon spacecraft, and a contract to develop a lunar lander for NASA's Artemis program. Hello everyone, and welcome back to the channel. In today's video, we'll focus on SpaceX and discuss the technology that drives the company. But first, make sure to subscribe to the channel for more similar content. Let's dive in. SpaceX's Starship rocket exploded on Thursday, minutes after lifting off from a launch pad in South Texas. The rocket, the most powerful ever built, did not reach orbit but provided important lessons for the private spaceflight company as it worked toward a more successful mission. And that certainly doesn't take away from all that the company has done so far. One of SpaceX's most renowned creations to date is the Falcon 9 rocket. The Falcon 9 rocket is a two-stage rocket designed and manufactured by SpaceX. It stands 70 meters tall and has a diameter of 3.7 meters. The rocket is powered by 9 Merlin engines in the first stage and a single Merlin engine in the second stage. The Falcon 9 is designed to carry payloads to low Earth orbit (LEO), geostationary transfer orbit (GTO), and beyond. It has a payload capacity of up to 22,800 kg to LEO and up to 8,300 kg to GTO. The rocket's first stage is designed to be reusable, which helps to reduce launch costs. The Falcon 9 has undergone several upgrades since its first launch in 2010. These upgrades have included improvements to the engines, fuel tanks, and other components, as well as the addition of landing legs and grid pins to facilitate first-stage booster recovery. The Falcon 9's reusable design is a key engineering innovation that has helped to reduce the cost of spaceflight. The reusable design allows the rocket's first-stage booster to return to Earth after launch, where it can be refurbished and reused for future launches, rather than being discarded after a single use. The engineering behind the Falcon 9's reusable design involves several key components. 1. Landing legs and grid pins. The Falcon 9's first-stage booster is equipped with 4 landing legs and 4 grid pins that allow it to maneuver and land vertically after launch. The grid pins help to stabilize the booster during its descent, while the landing legs provide a stable platform for touchdown. 2. Boost-back burn. After separation from the second stage, the first-stage booster performs a boost-back burn to slow down and change its trajectory back towards the launch site. 3. Re-entry burn. As the booster approaches Earth's atmosphere, it performs a re-entry burn to slow down and protect itself from the heat generated by atmospheric friction. 4. Landing burn. In the final stage of the landing sequence, the booster performs a landing burn to slow down and land safely on a designated landing pad or drone ship. The reusable design of the Falcon 9's first-stage booster has allowed SpaceX to significantly reduce the cost of launches, as it eliminates the need to build a new first-stage booster for each launch. It also represents a major step towards achieving the long-term goal of making space travel more accessible and affordable. Another outstanding creation is the Dragon spacecraft. The Dragon spacecraft is a cargo and crew spacecraft designed and built by SpaceX. It is capable of carrying both pressurized and unpressurized cargo, as well as crew members to and from low Earth orbit destinations, such as the International Space Station (ISS). The Dragon spacecraft is composed of 2 main sections, the capsule and the trunk. The capsule is designed to carry up to 7 astronauts and features a re-entry heat shield for safe return to Earth. The trunk section houses the spacecraft's solar panels, communications equipment, and other support systems. The Dragon spacecraft is launched into orbit using a Falcon 9 rocket and is capable of autonomously docking with the ISS or other spacecraft in orbit. Once docked, the Dragon can transfer cargo or crew members to and from the ISS. The Dragon spacecraft is also equipped with a variety of safety features, including an emergency escape system that can be activated in the event of a launch emergency. Next comes the Starship. The Starship is a next-generation spacecraft being developed by SpaceX to transport humans and cargo to the Moon, Mars, and other destinations in the solar system. The Starship spacecraft is composed of two main sections: the Super Heavy booster and the Starship spacecraft itself. The Super Heavy booster is a massive rocket that's designed to provide the initial thrust needed to launch the Starship spacecraft into orbit. It is equipped with up to 31 Raptor engines, making it one of the most powerful rockets ever built. The Super Heavy booster is also designed to be reusable, with plans to land it back on Earth after launch for refurbishment and reuse. The Starship spacecraft is designed to carry up to 100 passengers and cargo to destinations beyond Earth orbit. It features 6 Raptor engines and is designed to be fully reusable, with the ability to land safely on the Moon, Mars, or other planetary surfaces. The Starship is also equipped with a variety of life support systems and radiation shielding to protect its passengers during long-duration spaceflight. The Starship spacecraft is still in the testing phase, with several prototypes having undergone test flights to date. The ultimate goal of the Starship program is to enable the colonization of Mars and other planets, making human spaceflight more accessible and affordable in the long term. Technology has played a crucial role in SpaceX's success as a space exploration company. SpaceX has focused on developing and using cutting-edge technology in every aspect of their operations, from rocket design and manufacturing to mission control and logistics. Some of the key technologies that have contributed to SpaceX's success include: 1. Reusable rocket technology. SpaceX's reusable rocket technology has allowed the company to significantly reduce the cost of launching payloads into space. By developing rockets that can be reused multiple times, SpaceX has been able to disrupt the traditional aerospace industry and make space exploration more accessible and affordable. 2. Autonomous systems. SpaceX has invested heavily in developing autonomous systems for rocket landing, spacecraft docking, and other operations. These systems allow SpaceX to carry out complex space missions with a high degree of precision and accuracy without the need for human intervention. 3. Advanced materials. SpaceX has developed and used advanced materials in their rockets and spacecraft, such as carbon fiber composites and 3D printed components. These materials are lighter, stronger, and more durable than traditional materials, which has helped to improve the performance and reliability of SpaceX's vehicles. 4. Data analysis and machine learning. SpaceX uses data analysis and machine learning algorithms to monitor and optimize rocket performance during flight. These technologies help SpaceX to identify and correct any issues that arise during a launch or landing, improving overall mission success rates. Whether you like him or not, you cannot deny the efforts of Elon Musk to bring SpaceX where it is today at the forefront of space research. That was all from us today for this video, folks. See you in the next one.